Hello, my name is Daksha Vijay Kumar, and I'm here to present E278 Mini Project 4, and the topic is CNN weight compression using vector quantization. So, the deep neural convolution neural networks have become the most promising method for object recognition, image classification, and even object detection in recent years. However, a convolution networks nowadays makes the storage of the network model to be extremely large. So, for this purpose, the goal of this project is to develop a CNN weight compression strategy for digit recognition. So, as you can see, this is a simple CNN model wherein it has 20 cross 20 input neurons and 25 neurons in the hidden layer, and finally we have 10 output neurons across the output. So this is a generalized number that I've taken. So in this project we must compress the weights using the vector quantization technique and provide the compression ratio as well, and finally I have demonstrated the accuracy results for each quantization strategy. So the algorithm that I've used for to train the codebook is algorithm description, is Lindo Boozer-Gray algorithm. So you can see the steps involved in the Lindo-Gray's algorithm. So first step is to take an image as an input, and secondly we decompose the image into non-overlapping blocks, and next step we select the n value n vectors arbitrarily, and in the next step we group and compute the centroid, and the next step we check for the convergence, and if there is and if it is true, then finally codebook is being computed, and if not, it goes back to the step where we group and compute the centroid. So this is the original matrix, and we select a 2x2 code vector from this original matrix, and that is used for to generate a codebook. And as you can see, this is the a matrix which has the minimum square error, and the row number is mapped according to the codebook, and this is the compressed form. And let's discuss about the design that is being used in this particular project. So it goes to many steps like quantization, compression, and decompression. So in the first step, at a point of quantization, we convert values of double precision format into fixed point format. The fixed point formats can be in int4, int8, int16, and int32 formats. So so the algorithm used for quantization is as shown here. So first we select the fixed point binary format, and we follow many steps such as reserving 3 bits for integer presentation, and we pick the row and column of the address book, and we multiply the theta value with 2 power n, and so this is the basic algorithm of a quantization that I use in this code. And finally at the last step we compute the theta quantized matrix, and in the next step we compress the theta 1 and theta 2 matrices from the quantized matrix. So here we generate address and codebook using the Lindo Boozer-Gray algorithm. And since the transmitter and receiver has the same codebook, the address book containing compressed image is sent from transmitter to the receiver. And this is the parameter values of the code vector, codebook, and address book, and theta 1 matrix. And similarly, this is the values for theta 2 matrix as well. And in the next step, we decompress the values of theta 1 and theta 2 matrices. So in this process, we generate original theta 1 and theta 2 matrices from the codebook and address book. After decompression, matrices are converted back from fixed point format to double precision format, and the accuracy is calculated in MATLAB. So this is the analysis and the results part, and you can see that the accuracy or the vector quantization levels it increases as we go higher up the data type number. So if you can see the info format, the accuracy is just 15.99%, and it increases to 92% for the 32 in 32 data type. And as well as you can see that as the codebook size decreases, uh, then also the accuracy or the vector quantization level drops. So we can conclude that using the vector quantization technique, we have compressed the weights and, and the corresponding degradation in accuracy for each quantization scheme is also shown here. And with this help of this project, I can conclude that depending on the data types, the accuracy and uh, the compression ratio changes. And as you can see, the 32-bit data type has more accuracy compared to that of int4. And this is my conclusion. And I guess like I've covered most part, or like how I approached the project, and I finally presented my results table. So thank you for listening to the presentation, and see you.